All right, good morning, e-learners. We are going over homework right now. Questions?
Why did we have to do it?
Some questions will not be answered. That's one of them. If that's truly your question.
Did I have
Yes, you did. All right, no questions really. I'll just say, usually when there is an issue, it's because the diagram is complicated. And what I've told everyone, at least many times that when I've spoken to you, is like, try to declutter the image to just what you need to see. When they have all those extra lines on it. What's up?
number 12? Blue green.
What, did you figure it out?
I did not.
All right, so let's look at number 12. All right, Numa, smooth. That's 12 in German. All right. Number 12 is the hardest one. It is the hardest one. So you get this, I don't know, sawtooth-looking shape right here. So you get basically something that looks like this. You got these two other triangles, look like this. And you are told that this one is parallel to this one. And then I need two of these. This one is parallel to this one. Yeah?
Yeah.
And then further you're told that this is y. The bottom here is 55. This is x. And this is 50. Okay, there are many ways to solve this. But one way would be to think about this. All right, declutter the image, right? There's too many lines there. Let's just do two of the parallel lines. So I'll take the ones with the single diamonds first. So here's a decluttered image with just the two diamonds. And you're like, it doesn't look like that. Yeah, but remember, lines are now, they extend forever. They don't put arrowheads on it. That's the picture of just the one diamond. I did it. I mean, if you look at the actual picture, I confused the two with the one diamond, but we'll get over it. Okay. So we know for this shape that this is 50. And on this diagram, therefore, what else do we know must be 50? This piece right here, where is that on our shape?
Why?
No, that's on the other side.
It's right here. So, but I do know that this is 50 now. Okay. Can we tell anything else? We also know that this angle here must be.
Why?
No.
No.
the angle
But I'm
must,
saying this must be what degree?
it must be
180 minus
One, which would be
130.
130. So we know, now this is harder. You got to say, well, where would the 130 be? That would be from here to here. That would be 130. Okay. I don't know if that helps, but it's 130. Can we get anything from that shape? We could get this one, but that's not part of our shape because that would be alternate interior. And I think that's it, right? Okay, I'm done with 50. What's the other number up there? 55. So I'm going to declutter that one. So that's this, and that's this one, and this one. This one, and this one. And we are told, oh wait, not this one. Sorry. That's this one, and that. And we're told that this is 55. Therefore what?
Where did you get that?
It says right here.
No, I'm talking about
I got this line, and that line. You see it? So if this is 55, what else do you know?
The alternate interior 55.
So that one right there, where's that? That's this piece right here. So now I know that this is 55. All right, I still don't have anything yet. Or do I? I do. Alternate interior. So if this is 55, this is 55. Now we're just left with y. All right. The easiest way to think about y would be this.
Figure out what 130 minus 55 is.
Oh, no, okay. Oh, yeah, yes, absolutely. And that would be y because that would be corresponding. Okay, so what's 130 minus 55?
105.
What is it?
75.
Is it 75? Okay, that works 75. Is that right? Yes, that is right. There you go. Difficulty level of this one. Easy, medium, hard. This one's hard, right? In a non-honors class, or in an honors class, this would be their test question. And I would feel no pain or suffering, like, suck it up, Buttercup, do it, right? That's why you're in an honors class. In a regular class, this would be like an extra credit problem, right? I do assign it because I also need to, I mean, there's people in here who can do this. How many people got the answers, by the way, for number 12? I mean, there's people in this class that got it. Some, I mean, I don't believe I gave any of you help on number 12. I did give the honors kids some help on that one, but I didn't give any of you help, and you got it. So there you go. You're doing honors work right there for that one problem. I don't want you to panic about that one because that one is a panicky problem, right? Like literally what he said, it really messed with my brain, right? When someone shows you, like, how come I couldn't do that, right? Because there was nothing that I did there when I was showing you that you weren't able to handle, but it's a challenging one. All right.
There was so much I couldn't declutter it out.
Exactly.
What's
And
going
the
on?
decoloring thing will be something, but maybe by the end of the year you'd be able to do something like that, but certainly now it's a challenging one. All right, here we go. 1 through 13 all. Number 1, that would be what? Angles 3 and 6. Yes? Have to be congruent to 1. 6 by vertical, you don't have to put the reason. 6 by vertical angle and 3 by 3. I'm sorry, 9. Is it 9 or 3? No, it's 3 and 9. 3 and 9. Okay.
Okay, what is happening? I'm not doing.
Once again, I would declutter that image. So if A is parallel to B, then 1 and 3 are corresponding, and 6 is vertical. Did anybody put 8 as well?
I got 3, 6.
Yeah, and 8 would be true as well because it's vertical. Now the book kind of left that one out, but I would include 8 as well too.
I think 4 corresponding.
Which ones?
4 vertical angles, which I know are all congruent, and the corresponding are all congruent. So technically, you get 8.
Which ones did you put?
3, 6, 8, 9, 11, 14.
Well, okay, so as soon as you jump to the bottom, we do not know until number 2 that C and D are parallel. So for just question number 1, then 3, 6, 8 would be the ones you should have. All right, but number 2, now we get 6, 9, 14. All right, number 3, now that we know that A and B and C and E, now we got a big Mongasso list. So in no specific order, for answer number 3 is 4, 5, 7, 10, 12, 13, 15. Yes? Okay. Number 4, once again, another big Mongasso list. 1, 3, 6, 8, 9, 11, 14, 16. That's a lot. Number 5, measure angle 15. Measure angle 15 is 110, and angle 3 is 70, 70. Number 6, all right, this was the weird one. Well, measure angle 12 has got to be x then. And that's not a very satisfying answer, but that's the answer. And then lastly, 6, this is the more challenging one. You've got 6, good job on you. 180 minus x, right? You just got to be comfortable with that being an answer rather than being, oh, it's 13 degrees. All right, number 7, x is 60, 60, and y is 61. Number 8, x is 10, y is 45. Number 9, x is 60, 60, and y is 18. Number 10, x is 70, and y is 60. Number 11, x is 14, y is 9. And we already talked about 12. X is 55, and y is 75. And that's it.
I'm not sure what happened here. I didn't get numbers for the first 6.
What were you doing? Spacing out?
No idea.
Circle them and I'll go. Good question.
Maybe angles more like what they are.
I don't know how I got number 12 right. I got a bunch of them.
Oh, no.
You got number 12 right. You got some other ones wrong. I'm impressed. Unless you took a wild guess.
Yeah.
All right, everyone else, let's see. We got a quiz tomorrow. All right. Hey, Danny and Chris, can you collect and do that stuff and watch me at the same time?
Nope. All right.
Here we go. If two lines are parallel, right? And I had another one that's parallel to the first, what can you say about the first and the last one? Here, I gotta use this. Here's my other one. So this one is parallel to this. This one is parallel to the yellow one. What can you tell me about these two? They're parallel to, are all three parallel now to each other? Are all three of them parallel?
Yes.
So there's one plane that could touch all three of these at the same time. Which plane would that be? Just put it.
This
That would be intersecting, right? No. There's one plane that can touch this, right? There's one plane that can touch this. When you put three of them together, now there is a configuration. Now one plane can touch all three. But there's another configuration where this is parallel to this one, this is parallel to this one, but the three are not on the same plane.
Oh.
They're on a different plane, right? Two of them could be on the same plane. Any two of them could be on the same plane, but all three can't. However, if I make them literally like this, they could be on the same plane. So sometimes they're on the same plane, sometimes they're not. But what we said about the first two is true. If this one is parallel to this one, and this one is parallel to that one, what can you tell me about these two? They're always parallel, okay? You might want to remember that. Let's see, what else? We're going over quiz stuff for tomorrow. I got to look. I can't remember what I put on the quiz. Oh, yes. If I give you two parallel lines cut by transversal, can you tell me all corresponding, all alternate interior, all alternate or same side interior? Can you tell me all those angles? All right. That would be a pretty easy quiz, right? That's what the quiz will be on.
Really?
Yeah. All right. Last one. If two lines do not intersect, are they always parallel? If two lines intersect, are they always parallel?
Oh, no, they could be a skew.
And it could be skew. So is this an always, sometimes, or never? This is a sometimes. If two lines do not intersect, sure, they can be parallel, but they also could be skew to each other. Okay? All right, I just told you what's on the quiz. Shame on you if you don't get an A. Oh, maybe I should write that down. I'm speaking in codes. All right, today is a busy day. I think I can get through the whole class. We're going to see. We'll see. All right, copy down your homework. If I don't make it through, then we will still have the quiz tomorrow, but we will finish the class. No, we'll take the quiz first. I think I can make it through, but maybe not. This is the one that was kind of iffy on. There's a lot of stuff today. Geometry, I know I said this in the past. So geometry course, every year I will finish early. And so this year I'm trying to make, I haven't taught a non-honors class in a long time. And I want to make sure that I give you guys all the opportunity to get a good grade in the class. We're not there yet, but we'll eventually get to where we get some more skills-based things. There's some formulas and whatnot. We get to things like that, we'll probably take a day, a rest day, and just have a class of practice if there's a skill. Bailey's still absent? Yeah. So I can't give you your quiz back or your test back. Or did I already give you your test back?
Yeah, we got it.
Yeah, I didn't think so.
Can we please see it?
I can tell you what your grade is.
You promised we could see it.
Well, I thought Bailey was supposed to be here yesterday and she was going to take her test. And then I got confused with Maya and, well, I'm old. Okay. Proving lines are parallel. Okay, we're going to take what we learned yesterday and we're going to do the reverse or the converse of it, right? We're also going to add 3 other things that kind of have nothing to do with yesterday's class as well, too. That's the part where I think I might run out of time. We'll see. All right, a lot of theorems and postulates today. Here we go. From the last class, we were talking about this construction. This is the construction where you have 2 lines that are parallel, H and K, cut by transversal. All right, Karis, you're on. We'll play the same game as we did yesterday. You name something, say a theorem or a postulate, and Amaya has to name the angles.
Okay.
But it's got to apply to the two parallel lines cut by transversal. You name the postulate or the theorem, and she's going to name the angles.
Okay.
Which one are you picking?
Interior.
Alternate interior angles, theorem, whatever, are congruent. Name them.
3 and 5.
Keep talking. 3 and what?
5.
What did she say? Name it. Say it again.
Interior.
Alternate interior.
3 and 6.
You're alternating top to bottom, left to right. So 3 and 6 and
4 and 5.
and what do we know about 3 and 6 and 4 and 5? If it's this construction, are they the same or different?
The same.
They're the same. Okay. All right. Wes, you name the thing, and Madison's gonna. Corresponding angles are congruent. Go for it. You got the hardest one. Go. What? 3 and 4 are not corresponding. 1 and 4 are not corresponding. Tomorrow in the quiz, I'm going to say name the corresponding angles. You're going to have to be able to name the corresponding angles. Wes, can you help her out? Not telling her the answer, but telling her what a corresponding angle is.
So if you were to ask, I'm like in the top left, they would be in the same.
Top left to top left. So 1 and keep talking. Keep talking. And are they the same or different? So when we say those two angles, 1 and 5, are they the same or different? They are the same. That's what congruency. It means their measurements are the same. It means you can say they're congruent. All right. Let's go up front here. You name it. Seth, you got it. So what's left? There's 2 of them that are left from yesterday. We said alternate interior. We said corresponding. There's 2 of them that are left. We didn't talk about external yet. We will today. So we had alternate interior, corresponding. There's 2 more from yesterday. Same
side.
Same side interior angles are congruent or not congruent? They are not congruent. Check it out. Acute, obtuse. They're not congruent. Same side interior angles are, you can look through your book of truth. Huh? You wrote it down. Matt, help her out.
What are we doing?
Same side interior angles are,
Um,
for this construction.
they're on the same side of the interior.
What do you know about them?
They are supplementary.
They're supplementary, meaning they add up to 180. All right, Seth, what are the same side interior angles?
We have 3 and 5, 4 and 6.
All right, we had the last one. I'll do it, and it's not this picture, but if 2 lines are parallel and one of the transversal is perpendicular to one, what can you say? 2 parallel lines cut by a transversal. If the transversal is perpendicular to one, I don't mean one, the angle here, one of the lines, then it's perpendicular to the other. All right, you're not giving me much confidence here for that one. All right, so those are the 3 that we have. Now, there was that 4th one about the perpendicular one. I left that one off. That's also corresponding, right? Because if it's perpendicular to that one, then the corresponding angle for the other one would be perpendicular as well too. All right, so what is, does the converse work with this for each one of those statements? All right, well, let's look and see what the converse statement would be. So given this construction, what was the first one we had? You gave me what? Alternate interior angles. If the alternate interior angles are congruent, does that mean the 2 lines must be parallel? Okay. What would be the other one? Who gave me the next one? You gave me which one?
Corresponding.
If corresponding angles are congruent, does that make the 2 lines parallel? Remember, the converse means we're not starting with the fact that 2 lines are parallel. Okay, we're starting with that second part, if corresponding angles are congruent. And the last one would be, if same side interior angles are supplementary, are the 2 lines parallel? So those are the converse statements, and that's what today's class is about. Okay, trying to prove the converse. Anybody want to take a guess? You think they're true or false? If I can show that corresponding angles are congruent, do you think the 2 lines are parallel? Somebody take a guess.
Yeah.
If I can show you that the interior angles are congruent, you think that means the two lines are parallel. And then lastly, if the two interior angles, same side interior angles are supplementary, you think that means that the two lines are parallel. Well, that's what we're going to do today. Let's find out. This was a postulate, so apparently I'm not going to prove this one. So one of those is certainly true. What did we have a postulate for the other three? Which one was it? Was it alternate interior? Was it same side interior? Was it the corresponding one? Which one was the postulate? For yesterday, which one was the postulate?
If two parallel lines are, what is that? Are they cut by a transversal, then they're
And their corresponding angles. And so the converse to that would be if corresponding angles are congruent, then the two lines are parallel. So that's going to be postulate 11, and it turns out it's true. Right? Now, we do not prove postulates, but this one might need a little bit of explanation. So it's saying if angle 1 is the same as angle 5, then you can immediately say that H is parallel to K. It's the converse to that postulate. What was it? 10? Yeah, postulate 10. So why wouldn't we have to prove this one? Well, the only way that angle 1 would change, look up here, the only way that you could change angle 1 is if I move this line. Now I'm making angle what? Bigger or smaller? Now I'm making angle 1. So if I move this line, then angle 1 isn't the same as angle 5. Well, then conversely, if I don't move it, that must mean they must be parallel to each other. And that's why this one is not proven, although technically I just gave you a weak proof of that. Okay, so it is a given, we don't prove this, that if you can show that any two, I don't need to show that all four pairs, just two. If you can just show that two corresponding angles are congruent, then you can conclude that H is parallel to K. Tonight for homework, they're going to say prove that H is parallel to K. So this is your first arrow in your quiver. Hey, how do I show that two lines are parallel? Show that any two corresponding angles are congruent. Girls, you paying attention? Doesn't look the way. Brain's got to be turned on. So the first arrow in our quiver tonight, it's going to say, prove that two lines are parallel. The line will be cut by transversal. So far, we got one arrow. Show that any two, 1 to 5, 3 to 7, 2 to 6, or 4 to 8. Pick any two, show that they're congruent, and therefore you can conclude that two lines are parallel. Got it? Okay. All right, that's the converse to postulate 10. What would a question tonight for homework look like, right, to use that? Well, here we go. Remember, the statement is if two corresponding angles are congruent, then you conclude that the two lines are parallel. So this is what a question would look like. You see it? All right. Does it say in the picture that L is parallel to M? Does it say that? It's asking you to prove that. So how many arrows do we have in our quiver right now to prove that two lines are parallel? 1. And what does it say? No. What does the one arrow say? I need to show that two corresponding angles are congruent. Does this picture show that two corresponding angles are congruent? Everybody? Does it show that? Therefore, what can we conclude? What can we conclude in that picture?
L and M are parallel.
We can conclude that. That's what tonight for homework will look like. Is that an easy, medium, or hard one? That is ridiculously easy right there. So let's look at a challenging one. You see it? Like instant headache right there. It's the same question. They just drew extra stuff there to confuse you. So with your eyeball, I'm not asking you to prove anything, with just your eyeball, Chris, which lines appear, remember we're talking to lines now, they don't have arrows on them. Which lines appear, don't look at the numbers yet, which lines appear to be parallel? You can use the letters, not the numbers yet. Just which one visually appear to be parallel? You got to give me two letters. Agreed, but which ones appear? Give me the two letters. W-O and it appears to be a parallel to yi. Okay, doesn't it not appear that those are parallel? If they're parallel, what must be true? If they're parallel, what must be true? Corresponding angles are congruent. Well, let's see. If we ignore these two right here, just ignore them, can you see the two lines? Can you see the two angles? Are the angles the same? So are those two lines parallel? You got to tell me you got that, yes or no. Are they parallel, yes or no? They are not parallel. How did I do that? Decluttering the image. It certainly looks like Chris was right. They certainly look parallel. I mean, they probably are parallel. They draw them that way and then put different numbers there to mess you up. What are the other two lines, Madison, that appear to be parallel? Okay, so OX and IZ, they appear. So once again, we'll declutter the image, right? Oh, wait, if I declutter the image, it would be this plus this, right? What's 52 and 28? What's 52 and 28? What is 52 and 28? Is it not 80? It's 50 and 30. So parallel or not parallel? They are parallel. It's the same angle. This one is a little bit harder. If we declutter the image, if I got rid of OW, it's not there. You got 80 degrees. If I got rid of IY, you got 80 degrees. Therefore, this line, IZ and OX. All right, easy, medium, hard. This is a medium one. Okay? The hard one is like that sawtooth one. And you will have at least one of those tonight for homework. Okay. Easy, medium. Both of these are in your realm of you can do this. Okay? How many arrows do we have in our quiver to prove that two lines are parallel? 1. We will have 3 or 4 by the end of the day. Okay. So we can conclude that OX is parallel to IZ, but not OW to IY. All right, let's do a proof. Once again, a nice, easy proof. You guys will be able to do this one as a class, right? We put our heads together, we can do this one. All right, so the given is that you got two lines cut by transversal. We're trying to prove that the two lines are parallel. How many arrows in our quiver? 1. Therefore, we must show what? Since we only have 1 arrow. To show these two lines are parallel, what must we show? That 2 corresponding angles are congruent. That's the only arrow we got. Are you with me? We're solving a proof now, so try to stay the logic with me. This is where your brain is 100% turned on and you're paying attention. Okay, so I got the given. This is where I'm going, and we just said that I know how to prove that they're parallel. I need to show that 2 corresponding angles are congruent. Hey, which 2 angles up here are corresponding? Which ones? 3 and 1. So I need to show that 3 is congruent to 1. If I can do that, I'm done. In fact, I can already write that in there. I can write angle 3 is congruent to angle 1, right? I don't know why they're congruent, but the reason that the 2 lines are parallel is because of postulate 11. So maybe you know what you're doing, maybe you don't. But we can say something about the picture. Danny, can you look at the picture right now and tell me anything that you see? Yep, they're all angles. The little arc means that this one is the same as this one. That's the given. We already got that statement. Can you tell me anything about the picture? 2 is the same as what? That's the given. Can you tell me anything else? Okay. Do you see anything else labeled up there, Danny? There is a K and N. Those are lines. Okay, we got that. That's also on the given. Can you see anything else up there that's labeled? Okay, that's part of the given. Anything else that's labeled? Okay, can you tell me anything about 3 and 2? Are they the same or different? Why are they the same? Because of the thing you can't remember, right? Help them out. Could anyone see anything other than that one fact? Once again, you may not know how the proof goes, but you should be able to say, hey, look, I got vertical angles. They're congruent. So you could say that, vertical angles are congruent. And oh, by the way, that must be the end of the proof because there's no more space there. So let's see if we can figure this out. It says 1 is to 2 and 2 is to 3. 1 is to 3. Well, how can I say that? You can either say substitution, or this is the classic case of transitive. He's the same as him, him's the same as he, and he is the he. Right? That's poor grammar, but that's transitive. I would not mark it wrong if you put substitution. Who's lost on that proof? Easy, medium, hard proof. I mean, the diagram, all we did, and all I said to Danny was tell me, he knew it, he just couldn't come up with vertical, right? But he could tell me something about the shape, right? There we go, QED. All right, by the way, we just proved that what? What did we just prove? That if two alternate interiors are congruent, then what can you say about the two lines?
Why did we just prove posture?
Well, yeah, because the other one isn't believable as a posh. I had to prove that one. All right, so we just proved that if alternate interior angles are congruent, then the two lines are parallel. We got arrow number 2 in our quiver. So now we have 2 arrows to show that lines are parallel. Hey, show me that corresponding angles are congruent, or show me that alternate interior angles are congruent. So now we have 2 methods to show that lines are parallel. Soon we'll have 4. But right now we have 2. And remember, geometry builds upon itself. We don't allow anything into geometry if we can't prove it. We do allow definitions, though. You get to make up your own definitions.
Wait. So if you have to prove something, in that I say I'm alive, but you can say I'm just a figment of your imagination.
Ooh, we're
That's
getting
one-
deep.
That's one thing that you can say that I can't prove against. Is that
Do you watch The Matrix over and over and over again?
Maybe a little.
All right.
Maybe just clips.
Yeah. So I'll stick to the math thing because those are a little bit easier proven than what you're asking, which is a hard thing to prove.
How can you prove I'm not a figment of all your imagination?
All right.
There's no pain, so he definitely is a figment of our imagination.
All right, here we go. So this is theorem 3.5. If you can show that, notice I'm not showing that both alternate interior angles are congruent, just one set of alternate interior angles. All right, so this is the converse to 3.2. If 4 is congruent to 6, then we conclude that 2 lines are parallel. 2 arrows. All right, what would the homework questions look? All right, easy, easy. They're both easy. All right, let's see.
You literally took pictures of the book.
I literally took pictures of the book, but not very good pictures of the book, right?
No,
My camera was like being finicky for me. All right. Okay, here's the shape. Do you see alternate interior angles on the shape? Do you see them?
Yes.
Okay, what's that number?
48.
What's that number? Is that the same or different? Therefore, what can you conclude?
They are
What is parallel? GA and EM are parallel. All right. Can you do it right this time? Now turn your head to the right. You did it wrong. Turn your head to right. Now we're looking at this line and this line. That's an alternate interior angle. What's the other one? Unnamed. So can you conclude that AM is parallel to GE? Yeah, but this says 44. What's that say?
Nothing.
Nothing.
For alternate angles.
No. If the lines are parallel. We don't know if they're parallel. So therefore, the only thing we conclude is that this one and this one, that goes with GA, and EM. So we can say that GA is parallel to EM, but the other one we can't unless, don't assume it's 90 degrees. Say, oh, I'll just subtract from 90 unless there's a square there. There might be a square. If there's a square there, then you can certainly do subtraction. Did that make sense? I'm claiming that one's an easy one. I'm claiming this one is an easy one. Okay. 46 and nothing. So can you conclude that LA is parallel to TS? All right. Now turn your head to the left. And you finally did it right. All right. We got 46 and clearly not congruent. Therefore, what can we say about the shape? Any sides parallel? None of them are parallel. Once again, easy, easy. This head turn thing is no joke. You got to do that, right? To figure out which ones are the alternate interior angles. Who's lost? All right, how many arrows we got in our quiver now? 2. Corresponding or alternate interior. Let's see if we can get a third one. Apparently, we're not proving this one. All right. If you can show that same side interior angles are what? Not congruent, but supplementary, then you can conclude that the 2 lines are parallel. So this is our third arrow to show that any 2 lines are parallel. Show me that same side interior are supplementary. Show me that same side. This is the converse of 3-3. For those of you that would like, I assigned this to the honors class. For those of you who would like, and you want to do number 22, I'll give you a point of extra credit on any test or quiz if you write up a proof for this. Write me up a proof and I'll give you a point on any quiz or test.
So it doesn't have to be right.
Oh, no, it's got to be right. You should be able to do this if you choose to do this.
Like number 22 in the book.
Number 22 for homework tonight. I didn't assign it for homework. And by the way, I can prove this. Remember, I said that I have to prove everything in class. If you want me to prove this, I will prove it for you. But I also want to allow some of you that are feeling pretty confident about doing proofs, try it. See if you can get it. So this is our third arrow. Show me that same side interior angles are supplementary. I won't say congruent. Supplementary, and the 2 lines are parallel. Yeah. So 3 arrows. We had 4 statements yesterday. We've only done 3, so there must be that 4th one. The 4th one was kind of a cheesy one. I said it's the same as postulate 11. We good? Can I move on? Okay. So what would that question look like? It would look like this. You see the shape? All right. Connor, what's 118 and 62? That would be 180. So guess what you just showed? You just showed that these 2 add up to 180. So guess what you can conclude now? Which ones are parallel? Top to bottom or left to right? Do you see the 2 angles? Okay. If these are same side interior, where are the 2 lines? Are we talking about left and right, or are we talking about top and bottom? We're talking about top and bottom. Therefore, you just show that they're equal to 180. Therefore, which 2 lines are parallel? Say it one more time. One more time? Say it again. All right. You just told me top and bottom were parallel. Yes? Give me the letters for top and bottom. Because you didn't say what I was expecting. You said it correctly. You said the top and bottom are parallel. So now give me the letters that define that line. Go start with the top. What's the top? KC and there you go. So KC and D are parallel. All right. Tilt your head the other way, right? So let's see. What are the, for the left and the right, or as you're looking at it, top and bottom now, it would be this one and this one. Do those add up to 180? Yes or no?
No.
Therefore, can you say that CE is parallel to KD?
No.
You can't. So that's it right there. That's what easy, medium, or hard. This one's an easy, right? That will what it'll look like. So that let's see. We got 3 arrows. Corresponding alternate interior, now same side interior are supplementary. 3 arrows. All right, the last one, write this one down. This is the converse, the one that we had the other day, which said that if you have 2 parallel lines cut by a transversal and it's perpendicular to the first line, it's got to be perpendicular. The transversal got to be perpendicular to the second line. So the converse of that is if you have 2 lines cut by transversal and the transversal is perpendicular to both, then the lines are parallel. But take a look at the picture. What can you tell me about these 2 angles? What's another name for them? What's another name? They're corresponding, right? So I'm going to claim that this is postulate 11. Like, why do we need this? There's probably one of the few theorems in the book. I'm like, what? Come on. That's just an extra one. Once again, if you want to prove this one in class or for extra credit, I'll give you a point of extra credit. This is number 23. You got to write this one up on a separate sheet of paper, and it's got to be correct. You get the point for extra credit. And if you want to call me out and say, prove it, I'll prove it for you. Oh, by the way, this is the easiest one to prove because of postulate 11. You good? So we got 4 arrows in our quiver. Show me that corresponding are congruent, 2 lines are parallel. Show me that alternate interior angles are congruent, they're parallel. Show me that same side interior angles are supplementary, they're parallel. Show me that they're perpendicular to the 2 lines, and they're parallel. Those are the 4 statements that you can make. Okay? You don't need to write that down, I just said it. All right, now the book gives a quick proof. I'm going to do it in class real quick for alternate exterior angles. I bet you guys can help me do this real quick. So let's just prove that if 2 lines are parallel, so this is L and this is N, and L is parallel to N. Let's see if we can prove that alternate exterior angles are congruent. I bet we can do this real quick. I'm not going to write reasons. I'm going to write statements. So I want to prove that 1 is congruent to 2. The 2 lines are parallel. Well, if the 2 lines are parallel, we got those other 4 statements. One of them says that alternate interior angles are congruent. So notice they're not labeled here. I'll label them. Let's call this one 3, and we'll call that one 4. If they're alternate interior angles, what do you know? Okay, so I can put the little arc thing right there. So I can say, you know, statement number 1 after the given, we can say that angle 4 is congruent to angle 3. Done. All right, Danny, you're on. Look at the board. What can you tell about angle 1 and angle 3? Because they're vertical angles, right? So we could say, another statement, we could say that angle 1 is congruent to angle 3, comma, and we could say that angle 4 is congruent to angle 2. Cool. Hey, but wait, 4 is congruent to 3. So anywhere you see a 4, I can write a 3. I'm trying to say that angle 1 is congruent to angle 2. That's how the proof ends. So let's see. Well, I got a 1 there, I got a 1 there. If I could change this 3 to a 2, I'd be good to go. Well, I can't change a 3 to a 2, but I can change a 3 to a 4, and I can change a 4 to a 2. So I can do a double substitution, and boom, I'm done. Write this down in your book of truth. It's not in the right order. Our book doesn't do it in the right order. It turns out that, we said this before, we thought it was true, that alternate exterior angles are congruent. We just proved it. You can now use that. Alternate exterior angles are congruent. And I'm not going to prove the converse, but the converse is true as well. If you can show that alternate exterior angles are congruent, then the 2 lines are parallel as well. The book talks about it briefly, and it says something to the effect that it says, oh, and you can also prove that alternate exterior angles are congruent. But it doesn't show you the proof. I just showed you the proof. So what about alternate exterior angles? Yep. 2 parallel lines are cut by transversal. They are congruent. And the converse is true as well. If you want to show that 2 lines are parallel, show me that alternate exterior angles. So now we have 5 statements. 1, 2, 3, 4, 5 that we can use to show that 2 lines are parallel. That's a lot of stuff, and this is where the class should end. It doesn't. All right? It goes on a little bit more. But this would be a perfect stopping point. And if I were writing the book, this is where it would end. But I didn't write the book, and I showed you the quick proof. Okay, what do you think? Easy, medium, or hard? Just look at the picture. You think easy, medium, or hard? This is a medium one. Okay. The technique that we're going to use for medium ones is decluttered. It says which lines are parallel. Once again, what does it appear to be parallel? Which ones appear? What? No pun intended. You didn't see it? What? What? All right. Which ones appear visually that they're parallel? Okay. H and T appear, and I mean H, I, and T. I'm just saying appear. Okay, but go with my question. Which ones appear to be parallel? How about W, I, and A, N? Let's see. If they are parallel, then we got those 4 statements that we can make. It's actually 5 now. You see this angle? You see this angle? If I exclude, right, these 2 right here, then you can see that those are corresponding. Can you see that? If I exclude the HI and the TN, then these are corresponding. Are those the same numbers? They're not parallel. What's the other possibility? These 2 right here could be parallel. Okay, so this one, their alternate, or their corresponding angle will be this plus this, and this plus this. What's 61 and 23? 61. Not 82. 84. What's 62 and 22? Therefore, what can you conclude? Which ones, and this is where the confusion will occur. You got to be careful. And that's why you got to be really careful. Hi, Tennessee. No, okay. All right.
They don't even look parallel.
Medium one. All right. I will show you this one example from last class. Bell's about to ring, but we'll get through this one. All right. Okay, so remember we got all those. Let's look at this sucker right here. All right, stay with me. This looks impossible. This is a easy / medium one. It's telling me that this line is parallel to this line. This line is parallel to this line. You got lots of parallel lines. If those lines are parallel, don't concentrate on the numbers yet. What can you tell me about these 2 angles? They are alternate interior angles, therefore they must be congruent. What can you tell me about these 2 angles? Therefore they must be. So we can make 2 statements. The first statement says that these are equal, and the second statement is these add up to. All right, let's write those 2 statements. What's the first statement? Doesn't matter the order that you do it in. Give me a statement. Give me a mathematical. I'm going to write this down. So tell me what to write. X plus 50. What does that mean? Their measurements are the same. So I could write X plus 50 is equal to 3x plus 20. Stay with me. What's the second statement I could write? Supplementary. So we're not going to write x plus 50 equals. We're going to write, what does that mean if they're supplementary? So what am I going to write? There are my 2 statements. You with me? Could we solve these? Well, clearly this one we can. This one has 2 letters. So let's solve this. What are we going to do? Let's move this x to this side. What does that give me? You're not with me. You guys are turning your brains off. It's going to give me 2x, so I'm going to get 50 is equal to plus. Move the 20 to the other side. Therefore, x is equal to. Okay. Could you take that value and toss it into the first one now?
Yes.
Okay. That's why we did that whole thing on solving a system of equations through substitution. All right. So let's throw this 15 in for where we see x. Where do you see x? Right there. In other words, right there. See what I did? 15 and 50. Talk.
60.
Move to 60.
60.
Therefore, y is
60.
Easy, medium, hard?
Easy.
I'd say this is an easy, medium one. All right. Hey, there are two theorems. Stop. There are two theorems that I did not get to. You need to write them down. They are Theorem 3.8. It's in your book, and Theorem 3.9. I need you to, tonight for homework, copy them down into your book of truth.
And they're
All right.
both on page 85.
All right, e-learners the same as you. I did not get to Theorem 3.8 and Theorem 3.9. I need you to, on your own, copy them down into your book of truth. They're both pretty easy to understand. And try your homework. You guys aren't sending me any email questions. However, if you do have any questions, make sure you get with me. A couple of you have not done well on doing your test and quizzes, meaning like you haven't even done them. So I've been putting zeros in the grade book. You need to stay on top of the class, e-learners. Tomorrow there is a quiz. I will have it posted by 3 p.m. in the afternoon, the quiz. I need you to take your quiz. You have 24 hours once I post it to take your quiz. Take your quiz. All right, talk to you guys later.